Greeting guys, so welcome back. So in this video we'll be seeing top 8 deep learning inference engines. So inference engines like DeepSpeed, FasterTransformer and vLLMs are designed to accelerate the process of generating the predictions from large language models by optimizing the computation and then the memory usage during the inference. So these engines are particularly useful in scenarios where the models are deployed for real-time application required fast and efficient processing of large volumes of data. So the first inference engine is FasterTransformer. So here is the GitHub repository, and this is specifically optimized for transformer based models including BERT and GPT, aiming to provide faster inference time. So in NLP, encoders and decoders are like two important components, with a transformer layer becoming a popular architecture for both components. And FasterTransformer implements a highly optimized transformer layer for both the encoder and decoder for inference. So FasterTransformer is built on top of CUDA, Kubeless and then C++. So they provide at least one API of the following frameworks like TensorFlow, PyTorch and Return backend. So users can integrate FasterTransformer into these frameworks directly. For supporting frameworks, they also provide example code to demonstrate how to use and then show the performance of these frameworks. So the second one in our list is DeepSpeed. So a DSpeed optimization library that simplifies this distributed training and inference, making it easier and more efficient to work with large models and also datasets. So DSpeed empowers the ChatGPT-like models training with a single click, offering like 50 times speed up over SOTA or LHF systems. Okay, so with the cost reduction at all scales. So it also employs various techniques to improve the efficiency, such as like model parallelism, pipeline parallelism and memory optimization. So DeepSpeed architecture allows for the scaling of training across multiple GPUs and nodes, making it highly suitable for large-scale models and applications. So its optimizations are particularly beneficial in scenarios where the model inference speed and then resource utilizations are like really critical. So here is the GitHub repository, and let's move on to the next inference engine, which is Tensor RT. So high performance deep learning inference, including deep learning inference optimizer and then runtime that delivers low latency and high throughput for inference applications. So a backend for ONNX models that allows you to like run ONNX models on NVIDIA GPUs using Tensor RT, which will offer a seamless integration for those like already working with ONNX models. So next one in our list is vLLM. So vLLM is a high throughput and memory efficient inference and serving engine which specifically designed for large language models. So providing a robust solution for deploying these models in scale. And then vLLM is fast and easy to use library for LLM inference and serving. So vLLM is like fast with state-of-the-art serving throughput and efficient management of attention key and values memory with paged attentions, and then continuous batching of incoming requests, and also fast model execution with CUDA or HIP grab, and then quantization. It support like GPTQ, AWQ, SKUs LLM, and vLLM is flexible and easy to use with like seamless integration with popular Hugging Face models, and also high throughput serving with various decoding algorithms including parallel sampling, beam search and more. And then tensor parallelism support like for distributed inference, and it can also support streaming outputs, OpenMeo compatible API server, and also support NVIDIA GPUs and AMD GPUs. And prefix catching support and multi-LoRa supports are available for experimental purpose. So moving on to the next inference engine, which is OpenMeo, an open source toolkit for like optimizing and deploying AI inference, offering like comprehensive support for a wide range of Intel processors and GPUs. So it just boosts the deep learning performance in computer vision, automatic speech recognition, and then natural language processing and other common tasks. It uses the models trained with popular frameworks like TensorFlow, PyTorch, and more. And it reduces the resource demand and efficiency deploy on a range of Intel platform from edge to cloud. So this open source version, which includes several components, namely like OpenMeo model converter, which is OVC, and OpenMeo runtime, as well as like CPU, GPU, NPU, multi-device and heterogeneous plugins to accelerate the deep learning inference on Intel CPUs and Intel processor graphics. So it supports pre-trained models from Open Model Zoo along with like 100 plus open source and public models in popular format like TensorFlow, ONNX, Paddle, MXNet, Caffe, Kaldi. So here is their GitHub repository. So let's move on to our next inference engine, which is FlashAttention. So it just focuses on fast and memory efficient exact attention mechanism, which can be particularly beneficial for models that requires like precision attention computation. So FlashAttention is an optimized attention mechanism which is designed to like enhance the efficiency and the speed of training transformer models by like reducing the memory excesses and improving the memory usage. So it achieves this through the use of tilling techniques operating on the blocks of attention matrix, which eliminates the need to store the entire matrix during the forward pass and recompute it during the backward pass. So this approach, which significantly improves the performance and scalability of like transformers, especially on longer sequence, by breaking down the computation into smaller chunks and iterating over like multiple softmax computation steps. So despite like requires more flops, which is floating point operations, due to the constant recomputation of softmax normalization statistics, FlashAttention is faster in like inference compared to the default attention mechanism, which focuses on the faster on-chip memory, which is SRM, instead of the slower high bandwidth memory like VRM of the GPUs. So this makes FlashAttention a highly efficient and practical choice for like training and inference in large-scale language models. So here is their GitHub repository. So we move on to our next inference engine, which is GVM, which is open source compiler stack that enables the efficient deployment of deep learning models on a variety of like hardware platform, including CPUs, GPUs, and specialized accelerator like Whisper C++. So a port of like OpenAI's Whisper model in C or C++, showcasing the ability to like deploy speech recognition model efficiently. Apache TVM is a compiler stack for like deep learning system. It is designed to like close the gap between the productivity focused deep learning framework and the performance and efficient focused hardware backend. So TVM works with like deep learning frameworks to provide end-to-end compilation to different backends. So the final inference engine is ONNX Runtime. It's a cross-platform high-performance inferencing and training accelerator which supports a wide range of hardware and workloads. So ONNX Runtime Inference can enable like faster customer experience and lower costs, supporting the models from deep learning frameworks like PyTorch and TensorFlow, Keras, as well as like classical machine learning libraries like scikit-learn, LightGBM, XGBoost. So ONNX runtime is compatible with different hardwares, drivers, and operating system, and provide optimal performance by leveraging the hardware accelerators. So ONNX runtime training can accelerate the model training time on like multiple node NVIDIA GPUs for transformer models with a one-line addition for existing PyTorch training script. So here is their GitHub repository to learn more. So that's it for today. So inference engines like DSpeed, FasterTransformer, and vLLM are designed with a focus on like optimizing the computation and memory usage during the inference phase of large language models or any large models. So they employ a range of sophisticated techniques and optimizations to enhance the efficiency and speed of like generating predictions, making them like invaluable tool for like real-time application that requires like fast and efficient processing of large volumes of data. So that's it, guys. I have provided the link to all the Inference Engine repo in the description below, and feel free to leave a comment and subscribe to our channel. That way you will get notified whenever I upload new videos. So stay tuned and bye for now. Thanks for watching.